All right, so we're live. Yes, we are live. First of all, let's give people like just a 2-3 minutes to join in. In case you're streaming live from YouTube and wherever, it would be nice to just give a shout out in the chats. GM everyone. Yes, we'll be starting in right now. Okay, yes, so we're going to officially start. Welcome everyone, GM guys, GM everyone, hello. My name is Cindy Kamau. I'm the developer relations lead for Celo Africa DAO. And welcome to our Celo Bootcamp to finish the year with a bang. It will be a 4-week, very intensive program to help you understand full blockchain development. And yes, at the end of it all, we'll have built an NFT marketplace from scratch. So I'm so excited to meet you guys. I'll let first of all Jordan to introduce himself before giving you guys the agenda of today's session. Hey, Jordan.
Hi, GM. Nice to see you back. So my name is Jordan Muthemba. I'm a smart contract wizard. Today I'm a wizard. We're gonna do a lot of magics in this bootcamp. And welcome.
Okay, yes. Just to give you guys a little bit of an introduction. So today's session, the agenda will be more of a general introduction to blockchain. We'll be covering foundational concepts like what is blockchain. We'll go through several demos to help guys understand how blockchain works. And yes, and Jordan will give us a quick introduction to Celo, and we'll give you guys an assignment for week 1. In case you're following, please follow Celo Africa DAO at Celo Africa DAO on Twitter. Follow us, Celo Kenya on Twitter. And yes, it's so nice to meet you guys. So just a second, I quickly share my screen to show you guys the slides. Okay, I hope you guys can see my screen properly. Yeah. Okay. In case of anything, Jordan, you can see my screen also, right? Because I might not be able to see the chats.
Yes. I'm also able to see your screen.
Okay, awesome. So the agenda of today is to welcome everyone to this session of the Celo Bootcamp, to give you guys objectives of the bootcamp and the schedule, and an introduction to blockchain technology. We're going to go through some of the key concepts of blockchain, what makes a blockchain to be blockchain, right? And then we'll go through an introduction to Celo. We'll also show you guys how to set up the development environment, then give you guys the assignment for today's week. Yes. Okay, so this is just a high level overview of blockchain. What is blockchain exactly? By the end of this session, it will be you have understood properly what is blockchain essentially. But before going through that, let me just give you guys the let me just give you guys a quick overview of the entire agenda. So during During this first week, week one, we, as I said, we're going to have an introduction to blockchain and Celo by me. We're the ones who are conducting the training live stream, so Cindy and Jordan. And also we'll be offering office support hours, so you meet the rest of the Celo Africa DAO team members, where during the course of the week, by next week, on Thursday, as we go to session 2, you guys will have, in case of any questions, any blockers when doing the assignments, we'll all be here to offer office hour support. Yes, so our first session is today. So it's just a quick introduction to blockchain and all. So in the next coming week, we're going to have an introduction to smart contract development after we've gone through the essential introduction to blockchain. So we're going to introduce a programming language called Solidity, which is used as a language to write smart contracts in most of the networks in blockchain, right? Which are based on Ethereum. Yes, so we're going to introduce a programming language called Solidity. We're going to go all this through the intro to Solidity, the syntax, and all the data types and events and all. Yes, and then we're going to introduce the smart contract, which we're going to write, which is an NFT smart contract. Technically, it's called an ERC 721, but we're going to go through all the nitty-gritties later on. And then the other week, we're going to now go through front end, because blockchain development is not just about building smart contracts. There's also the aspect of front end. So we're going to take you through how to deploy, or rather build a front end, which is like Web3 native, and connect it and integrate it with your smart contract. So that will be our session for week 3. And then week 4, we're going to finalize everything, because during week 3, we are going to learn front end through developing the interface for the NFT marketplace. So we're going to show you guys, we're going to all build how the interface for our marketplace, right? And then finally, we're going to finalize it. We're going to deploy everything and ensure our NFT marketplace is live. So by the end of the 4 weeks, we expect you guys will have a live marketplace, which you can also use to show in your resumes when you're applying for jobs, that you have a live product which you've built end to end. And this is the goal that we have for this bootcamp. We want to show you guys an all-rounded view when it comes to blockchain development, and not just bits and pieces, just to show you guys how to connect all the jigsaw puzzles boxes into an entire picture, right? So this is the this is just a quick overview of the outline. I'll be sharing it in the Telegram, in our dedicated Telegram group. So if you haven't joined our Telegram group, kindly join. We'll share the details as we continue on how you can join the dedicated group. So you can also access some of the mentors which we'll be bringing in for our office hours. So with that, I think we can now start officially. Yes.
Awesome. Let's get started.
Yeah, let's get popping. Let's get popping, guys. Okay, so blockchain, in the most simple terms which I could think of, it's just a technology for keeping records. Okay, so it's a record keeping technology, which makes it very impossible to alter the data which you've recorded in your records, right? Normally, when you even Google what is blockchain, you normally see like it's a digital ledger, but some of the times the explanations that we have of blockchain is a bit abstract, so it might not be quite easy to understand. But in essence, it's just a way of keeping records, any form of records, whether it's data, whether it's financial data, and wherever. It's just a form of keeping records in a way that cannot be altered by anyone. So technically, we say that's immutable, but in essence, it's just a way of storing records. Okay, and it makes it very impossible. Once you've stored anything in the blockchain as a record, it makes it impossible to alter the data which you've stored it, right? Yes. So the key things you normally get is it's a record keeping mechanism, and it's immutable. Like I said, you cannot alter it, and it's secure. But why is it that way? We're going to check as we continue. We're going to fully understand how blockchain works, right? Yes. So I have an analogy to help you understand how blockchain technology works. For guys who are in Kenya, we use every day a service we call M-Pesa. If you're not in Kenya, it's just the concept of mobile money, which applies to a lot of countries in Africa, essentially. So in Ghana, I know there's Momo mobile money. I also know in Nigeria, there's also other aspects of mobile money there, right? And also in some countries like Tanzania, they also use M-Pesa, the same as us, right? So M-Pesa is actually used in other countries as well, not just in Kenya. So when you look at M-Pesa, first of all, it's under the company we call Safaricom, right? Which is a telecommunication company, okay? And when I was checking the data, I saw right now, as of the current data, in Africa, over 50 million people use M-Pesa. That is a huge number of people who interact with money on mobile, right? So one thing to note, which will be key as we continue, is all of this data is in the Safaricom servers, right? So this will be a very important note, which we'll come back to it later, why I highlighted it, right? So when we use M-Pesa, essentially, we trust that Safaricom is going to handle our transactions, okay? So if I'm sending Jordan money, I do trust that Safaricom is going to process the transactions. Jordan receives his 100 Kenya shillings well, and nothing goes wrong along the way, right? And we also trust that Safaricom won't steal our money, because remember, all our money is in the servers of Safaricom, right? So if they can decide to wake up one day and clean out your M-Pesa, if you had, let's say, 1,000 sleeping and then you wake up and you have zero, there's nothing we can do, right? So we trust Safaricom that they can handle our transactions, right? Now, the concept of trust is also something else which we'll come to see. It's a double-edged sword, okay? So trust is something which really works a lot in our current, even when you check our current financial status in the Web2 space, right? Because if I put money in a bank, essentially I trust the bank first of all, otherwise I would not have opened an account with them, right? So I trust the bank to keep my money safe. I trust the bank to handle my transactions well and not steal any money from my from my account. And I also trust the bank that if I decide one day to wake up and go withdraw the money in my bank, I can withdraw it, right? But why are we talking about trust? It's because when you check even the banking system, the current banking system that we have, the point that I pointed out some time back is, I trust that if I have a bank account, let's say Standard Chartered, if I decide to go and withdraw my money from my account and receive cash, I can do it, right? But we've seen scenarios where you have money in the bank, but you can't access it because the bank says they don't have money in their vaults to withdraw, right? So we've seen a lot of cases, even on a global scale. We've seen a lot of cases with that. There's actually recently, I don't remember if it was in the beginning of this year or last year, there was a bank in the US, I've forgotten its name. People were unable to cash out their money, right? So you have money in the bank, but you can't cash it out. That shows you how we operate on a very weak system of trust. You know, we operate and we handle so many things with values of millions, but we trust and the trust can be broken anytime, right? So that's some of the concepts which are the foundational concepts of why blockchain technology came up in itself, because the current financial systems has its own limitations. Okay, the example, going back to our M-Pesa, they have autonomy over our data. Remember, Safaricom has the data of over 50 million people, right? That's a lot of data on people, right? And also currently in Kenya, we are facing there's been a lot of allegations that Safaricom has been selling, rather giving out people's data to the government, okay, allegedly, right? So you can see why some of having central authorities wielding this much power over people, you can see some of the challenges and some of the problems which arise later, right? And also one other thing, Safaricom can decide, Safaricom's actually the ones who decide the transaction cost, right? If I decide to send 200, they are the ones who set the 6 shillings, right? So if they decide to hike price, the transaction cost of sending money, there's nothing we can do on our end because we'll still have to pay the transaction cost, right? So that sort of monopoly is not really good when it comes to handling these things, okay? So this brings us to the current challenges which we have in our M-Pesa structure, right? So I'm in Kenya. If I want to send money to someone, let's say even in our neighboring country called Tanzania, I have to use a service which is called M-Pesa Global, right? So it's kind of like a virtual ATM card where you can send money here and there, right? But now one of the major issues is the transaction costs are really high, right? Even if someone from let's say in the US wants to bring money to or send you money to Kenya, there's always, it's not very seamless, you know, that money can even take time to get into your account. And essentially most of the profits, where most of these companies get their profits from, it's from remittances, right? So on our end as the users, we suffer a lot because you have to pay a very high transaction cost, and also some of the times it might not work, right? So we near each other as countries, but sending money across people in these countries is one of the greatest challenges, especially when it comes to your current to the current financial structures we have, okay? Even when you check our banks, sending money from one bank account to another, it takes a bit of time to and essentially they're just subtracting from your account and adding to another account. But especially when you're sending from someone who's abroad, or someone who's abroad is sending money to you, that money can even take like 2 weeks to get to your account, right? So it's very inconvenient. That's the word, right? And also, like I said, Safaricom holds data of over 50 million people, right? And currently, we've been facing allegations that they've been facing allegations that they release some of the biometric data you have to like intelligence services in Kenya. So if you do something or you say something and you're marked down by the government, they use entities like Safaricom to even pinpoint where you stay. And because we use a Safaricom a lot, not just on M-Pesa, but also when it comes to like buying data, calling, they can even like trace your call logs and release this information to, let's say, intelligence services. So this means that we don't have autonomy over our data, essentially. And we also don't even know what type of data they have in their servers, because they don't release the servers in the public for you to see what sort of data they have on you, right? And not just Safaricom, but most of the central authorities, there's this issue. Even Google, we don't know which data Google holds, right? So there's that concept of centralization, which blockchain actually came to sort of remove, okay? So also we have to really trust Safaricom that they won't be malicious. I mean, how do we know someone from, let's say, who's working in Safaricom, how do we know they don't like illegally subtract like some small money from your account, you know, and then they put it in other people's account? We've even seen cases in banks, like sometime recent ago, there's a bank in Kenya called Equity Bank, where people woke up and their money was gone from their accounts, right? And the authorities in Equity Bank, they were never held accountable, right? So this is some of the challenges which you're facing in the current structure, right? So this is the current M-Pesa structure. You'll forgive the illustration. I'll make it a bit better, okay? So if I want to send money to Jordan, Safaricom is the intermediary, right? So Safaricom will remove 100 from my M-Pesa account and it will update it to Jordan's, right? So if I have 600, my current balance will be 500. Jordan has 1,000, so his current balance will be 1,100, right? So this is essentially the typical structure we have in a financial structure, where there's a concept of an intermediary. So why can't I, if I want to send money to Jordan, why can't I do it directly instead of having to involve Safaricom, right? So this is where blockchain comes in, because there's no central intermediary which intercepts or rather processes these transactions on your behalf, right? So it begs the question, what if M-Pesa was
Cindy,
run? Yes?
if I can add to the tariff part.
Okay.
Now imagine now, like the previous example. Now imagine you move on to another country, there is the tariffs at the border where you are doing more like transaction, and you get a lot of like you're being ripped off your cash, your hand and cash. That is a really big concept, and yeah, so you can go on with the M-Pesa part.
Okay, so what if M-Pesa was run on blockchain essentially? And by the way, Jordan, since I can't see, in case someone is asking questions, you're free to intercept me. And in case you have any questions, you'll be putting them in the YouTube chat. And also, if you want to speak, essentially, you can DM me on Telegram. Jordan will share my Telegram handle so that I add you to the studio, and then you can come in and you can ask your questions live. So there are two ways to it. You can either ask questions on the YouTube chat, which Jordan will be, as we continue, he'll be like checking out and interrupting me in case someone has any question. And if you feel you'd like to come to a stage live, I can send you the logins to essentially just come on stage, and you can ask your question live, essentially. Yes, so those are some of the house rules that we have, which, apologies, I forgot to state in the beginning of the session. Okay, so let's continue. So what if M-Pesa was run on blockchain, essentially? This is just a high level of overview of how the entire concept would look like, right? So I still have my 600 shillings. I want to send 100 shillings to Jordan, right? So obviously the one thing I will do is I'll put Jordan's number the way we just use M-Pesa, right? I'll put Jordan's number, I'll put the amount, which is 100, and then I'll send it to Jordan, right? Now, one thing which is different between now the concept that we have for M-Pesa and the concept that we have on blockchain is that Safaricom, that they're not the ones who are running the servers only. So in blockchain, you'll find in Kenya now, some people will, let's say we have 20 people, right? So they will be running these M-Pesa servers in different parts of the country. So essentially, if you want to run like a Safaricom server, let's say there's like a hardware requirements, you're given like hardware requirements, go buy this type of server with this type of RAM and all this, and then you run some type of software inside, and then you connect it to the network, right? So we now have 20 people all across Kenya who are running M-Pesa servers, okay? So if Safaricom is not the central authority, how does these servers, how do they process my transaction, Cindy's transaction, okay? So the one thing you'll notice, Cindy's transaction first, it will be sent to all of the 20 servers. We're going to, technically it's called like a peer-to-peer network, which you're going to continue, which you're going to see when we handle the components of a blockchain. But this transaction is going to be sent to all the 20 servers, right? Now, each node independently, they're going to verify that, first of all, the transaction is truly from Cindy. In technical terms, we're going to say they're going to check my digital signature, right? So let's say they're going to check it's truly Cindy who is sending the money, okay? And one more important thing, they have to independently verify that she has enough money essentially to send their 100 shillings, right? So this is some of the rules which are put when you don't have a central authority. These are some of the rules which are given out, right? And when we continue, we're going to call them like consensus rules as we continue, okay? So back to our analogy. The nodes have received this transaction and they're independently verifying that the transaction is valid, okay? So if the transaction was invalid, it would have been rejected, right? So if the transaction is valid, the process continues, okay? So now if the servers collectively agree that the transaction is legit, and which begs the question, so these servers, how do they agree that the transactions, remember they've come from independently verifying, right? So on a collective scale, how do they agree that the transaction is legit? Okay, so it's through a protocol called consensus, which we're going to which we're going to talk about more in detail. So they collectively agree, the 20 servers, that the transaction is legit, right? Now, remember, there's no central authority to say, hey, this server is the one which is going to add this transaction to the blockchain, because all these servers, they're not going to add at the same time the transaction to the blockchain. It's going to be specific servers which are going to be adding transactions to the blockchain, right? So we need to look for a specific server which is going to add the next set of transactions, and then another server adds onto the next block of transactions after these ones are finished. So that's how they work collectively as peers, as opposed to having, like, let's say, a central node or a central server, which, let's say, will delegate, and it will be like you're the one who's going to add a new transaction. Okay, so we're going to check out consensus more as we continue. But as we continue now, we have our server 5, right? Out of the 20, the server number 5, it's selected through the mechanism, and it's going to be the one which will add our transaction to the blockchain, right? So the server 5, it adds the transaction to the blockchain. And what does it add essentially? So these are some of the details which is going to add to the blockchain, right? So it's going to add my Cindy's address. In this case, let's just say it's my phone number, right? So it's going to say, okay, at this point in time, Cindy is address, right? Cindy this is the sender address, right? Now the recipient address, this is Jordan, right? And then the amount is 100 Kenya shillings. The transaction ID, which is similar to like the M-Pesa ID, and the timestamp. So think about this as the M-Pesa message which you receive after you've made a transaction. You have the M-Pesa ID, the ID you have received or you have sent. Yeah, think of that message as now the data which will be added to the blockchain, right? So now server 5 will add the transaction to the blockchain, right? And then we finalize the transaction. So Jordan will receive his 100. The 100 will be deducted from my account. His updated balance will be 1100, and because he had 1000 on his bank previously. And then now something which is very important is the server which processed the transaction is going to receive the transaction cost. If Safaricom, I mean, I know when we send 100, it doesn't have like a transaction cost, but let's say if it was 200, the 6 shillings, essentially it is Safaricom which are going to pick that as the transaction cost, right? But now in blockchain, the server which processed the transaction is the one which is going to receive that as rewards. Why do we say that? This is just to ensure that people are motivated to set up these M-Pesa servers. Otherwise, remember, the server is using electricity, it is using internet, because it always has to be online, right? So it needs you as a person who's setting up the server, you would feel motivated if you are earning from it impassively. Okay, yes, that's why this is an incentive model which was put in blockchain, so that to make people be incentivized to run the servers, right? Yes, so this is how essentially, if M-Pesa was running on blockchain, this is how it was going to work. As you can see, there is no central authority. These are just peer-to-peer models, right? So everyone is collectively agreeing on something and updating. So this is the difference between if M-Pesa was like the way our current system of M-Pesa is running, and to how essentially things run in blockchain, right? So this is how this is a good analogy if M-Pesa was running on a blockchain, right? In case you have any questions where we are so far, kindly add them to the chat. Jordan will be going through and interrupting me. Otherwise, if everything is okay, I think we can continue. But please feel free to interrupt me in case you haven't understood anything so far. Okay, great. So with that, we now come to the foundational concepts of a blockchain in itself. And as we continue looking through this, I have several, what's this terminology? I have several examples which we'll be going through interactively, just to help build up the theoretical information, because right now you're seeing blockchain in theory, right? So you can help build like the practical way of how blockchain works. Okay, so with that, this is what I was talking about, a peer-to-peer network. Okay, so all these nodes, when you set up a node, what this is a node is just a server, which we call in blockchain a node. Okay, so when you continue in a blockchain journey and you're seeing nodes everywhere, just know when you're coming from like a Web2 background, it's just like a server. It's just a dedicated name for it. Okay, so it's a P2P, or rather a peer-to-peer network. It's just all these nodes, they are interconnected, right? So when you join in on a network. So blockchain, we have something we call networks. So when you hear like Ethereum, Bitcoin, maybe Celo, all of these are networks. Now, all of these networks, they have their own nodes. Okay, so if you're running a node on Ethereum, you have to join in on the Ethereum network. If you're running a node in Bitcoin, you have to join in the Bitcoin, or rather, if you're running a miner in Bitcoin, you have to join the Bitcoin network, all of these things. Okay, so you configure the details to suit the network, right? So they are interconnected and they share transactions. And how do they share transactions? Essentially, when you go and check out how a peer-to-peer network works, because it's not just enclosed to blockchain, it's a distributed network system, which is called peer-to-peer, right? So what happens is this transaction, it's first broadcast to the nearest nodes, right? So now these nearest nodes, once they receive this transaction, it is their work to now share it to their peers. So example, back to our M-Pesa analogy of 20 servers, okay? Let's say server one, which is in Nairobi, let's say it's nearest, right? So server one might be the one which will receive the transaction first, okay? Now it looks for its peers, and then it transmits this information to maybe server 2, 3, 4. Now server 2, 3, 4, they transmit to 5, 6, 7. So they go this way until all the nodes in the entire network, they have received this share of transactions, right? So this in blockchain, we call it gossiping. And it follows the how just essentially gossiping works, right? So if you receive some information, the first thing you're going to do is you're going to gossip it to, let's say, your friend, and like, hey, this and this has happened, and then your friend is going to gossip it to someone else. So when you see the terminology gossiping, when you continue learning blockchain at a deeper level, that's essentially what it is. It's just sharing information across these nodes. So essentially, they just gossip with each other, okay? Yes, so just like our M-Pesa analogy, if you want to send money, the 20 nodes will gossip this transaction. Now, why is it a peer-to-peer network? Remember, let's say you yourself, you've set a server, right? And then that day, electricity goes off or something. If it was Safaricom, and let's say Safaricom electricity goes down, or the servers have a downtime, that day you're going to be unable to access M-Pesa because it was just a central bit of, they were just centralized servers, right? But if it was a peer-to-peer network, they ensure minimal downtime, because even if you yourself, let's say you're server 8 or server 15, if you go offline, the rest of the servers are still online. So they're going to continue processing the transactions until you get back online, okay? So that ensures as minimal downtime as possible so that people can continue doing whatever they were doing in the blockchain, right? So they can continue sending money and all these things. And one thing to note with the blockchain network, which I forgot to say, is as opposed to the current challenges which we were talking about, where if I want to send money to maybe someone in Sweden, or even as close in Africa, if I want to send money to someone in, let's say, Nigeria, it may take a longer and a very complicated process. But in the blockchain network, provided you have your recipient address, even if in the Arctic Circle or something, even if they are in Antarctica, they can receive that money in seconds, regardless of wherever they are. Once I'm sending the money in form of crypto, not in form of like the normal currency we have, in form of crypto, right? If I decide to send a crypto tokens worth, let's say, $100 to someone in Antarctica, regardless of the geographical location where they're placed in, they're going to receive this money in seconds. So these are some of the foundational concepts of why blockchain is a very important, and as we continue even in the world, it will become a very influential technology, because it's not hindered by geography at all. So it enables transactions between people. Essentially, it makes the world to be a small village, right? As opposed to the current financial settings that, and the current financial state that we have right now, right? Yes. So let me first go through this in an we're
There
first
is
going to
a
go through.
question. Sorry,
Okay.
there is a question. So Isaac is asking who pays the transaction cost to the server that adds the
Ah,
transaction to the blockchain.
so
Yeah.
just like you yourself, you'll pay if I'm sending money to Jordan, I'll be the one who will pay the transaction fee, right? So it's the same with blockchain. It's the sender who's sending the crypto to the receiver who pays the small transaction cost. And something which I forgot to add to mention is the transaction fees in blockchain are way lower than the transaction cost in let's say Safaricom, right? Because the Safaricom have this model, or rather M-Pesa, they have this model where they as you continue paying more money, you will pay higher transaction fees, right? But in blockchain, it's actually not the same, because you might find yourself even sending like $1 million to someone, and you'll be paying like, let's say, a transaction cost of $1. Transaction cost in blockchain, the essence of transaction cost, it's just like you're paying for permission to use the blockchain. So they don't even care that much about the amount that you're selling. You're just paying to use blockchain, so that because there are people who are maintaining it, because there's no central authority, and they need an incentivized model, right? So when you check the current M-Pesa, when it comes to transaction costs, you're paying based on the amount of money you're sending, right? When it comes to blockchain, you're paying to use the blockchain. Okay, that's why you'll find the transaction costs are really low. Like I said, you might send $1 million to someone in form of crypto, and you'll pay like a transaction cost of $1. And even that $1, people will complain that the transaction cost is actually super high. So some are based on the current structure that we have and the current improvements which are continuing in blockchain. There's this although we're not going to talk about it right now, but there's this concept which was introduced called blobs. You might BLOBS. As you continue, you can go check it out. But it was introduced, and it reduced transaction cost to be so damn low, such that you're paying like essentially you're paying cents, 0.000, let's say 0.001 or 0.0001, depending on the network. Okay, so that's the difference. So in blockchain transaction costs, you just paying to use the network. In the normal our M-Pesa, you're paying based on the amount which you're sending. Yes. I hope I've explained it well.
Yes,
Okay,
yes.
so
Actually, before you move on to, there is another question. Simon, So Simon is asking. There are actually two questions. So Simon is asking, where is all this information? Where is all information within blockchain stored? That is one. The other one, does cost not vary? Say, for I think that one you've answered. Does cost vary? Say, for example, if I want my transaction to be prioritized by the nodes, stroke proc.
yes,
Yeah,
yes,
they
yeah.
do.
Yeah, they
Uh,
do. Actually, thank you for reminding me of that detail. So, if let's say you want your transaction to be made faster, so you can pay more money so that the nodes who are processing the transactions, they prioritize your transaction. So this
yeah.
transaction, by the way, in blockchain, we call them gas fees. So you're going to see something we call gas fees, right? So if you want your transaction to be prioritized, you can pay more gas fees than someone who, let's say, just want to do what? Want to just be normal, okay? And why is that so? Because remember, the nodes, the way they work is they sort of they cherry pick the transactions which they want to process. Because remember, from a miner, or from a when you now you yourself, if you're running a node, you will want to make as much money as possible. So you're going to also look for transactions which have more money, okay? And you're going to prioritize that, because if you're the one who's going to run that transaction, you get more money, right? So if you want your transaction to be prioritized and it may be quickly, because sometimes in the blockchain network, you might find very many people are interacting with the network at the same time, right? Especially right now, let's say in the course of a bull run, so many people will be making transactions, so the network might be a bit congested. So you'll find if you pay more money for now gas fees, your transaction will be prioritized. Yes, so that's the concept. And also there was the other question, where is
Yeah,
this
there was the other. Yeah,
information stored?
yeah.
Yeah, so this information that's stored in something called blocks, of which when we start now doing the practical session, I'm going to show you guys everything, so you're going to understand. But this information essentially that's stored in something we call blocks. So just bear with me. Let me first finish the abstract or rather the theoretical point of view, and then take you guys to the practical session. Okay. So
For the person who is paying too much gas fee, they can be going through the link I've sent on the chat. Yeah.
okay, thank you. Okay, so transactions and state changes. In blockchain, I'm talking about transactions, right? But one thing I want you to understand is when I talk about transactions, it's more of like an umbrella term. Okay, so transactions, they're not just linked with financial transactions only. So there's so many other data which is stored in the blockchain, okay, not just financial data. And it's that data that we call not financial, sorry, transactions. So when you see the concept transactions in blockchain, don't just think of the monetary, like let's say I'm sending money here, I'm sending money there, because blockchain, apart from now the financial aspect of it, blockchain also has a very wide use case. Okay, yeah. So that's something I wanted to say. So why do we call them transactions? Remember, this blockchain of ours, if we want to update, and by update, what do I mean? When I come back to our M-Pesa analogy, remember the current state, and not the term I'm using, the current state, because we'll be talking about the blockchain state a lot. The current state of M-Pesa was Cindy had 600 shillings, Jordan had 1,000 shillings, right? So to update now the state of the blockchain, we had to make a transaction, right? So Cindy wanted to send 100 Kenya shillings to Jordan, right? So now we have to now update the state of our M-Pesa and by updating, I mean we have to introduce now the current information we have, right? That Cindy has 500 shillings now because we've deducted 100, and Jordan has now 1,100 shillings because we've added 100 shillings onto him. So, right? So that's what we mean by making state changing the state of the blockchain. Essentially, it's just updating it to maybe accommodate new information. Okay, so some of the components which you see in a transaction, it will be the sender and the recipient address, the amount of value, something else which is called the digital signature. When I talk about the digital signature, just imagine like how, let's say, you would sign somewhere. Now, when it comes to now a blockchain, we have this concept of digital signatures. This is just to verify that it's just to verify that you're who you're saying you are. And by digital signatures, I don't mean like you're making a signature online, This is now borders into some discipline which we call cryptography, which is another entirely different thing. But I'm going to show you guys a simpler way of thinking of signatures, right? The timestamp. This is also super important because we need to show that at 11 p.m., this is when Cindy sent money to Jordan, right? Just for making sure the data is just immaculate record keeping, right? So that in case anyone is challenging, or if I start saying, oh, I did not send money to Jordan, I did not send any, or Jordan actually starts saying he did not receive the 100 Kenya shillings, we can go back and show him on 11 p.m. On Tuesday, or let's say on Thursday, you received this money, right? And even your account was updated, and some other additional data which you're not going to get back to right now. Okay, yes, so that's it. Hi. Consensus rules, I want you guys to just think of them collectively as just the laws of blockchain, because remember, there's no central authority, and we don't want people to act maliciously, right? So how do we ensure everyone in the network is cooperating seamlessly? We cannot cooperate without a set of rules, right? So those are some of, we now call them like the laws of blockchain, okay? Because there's now central authority, and by that I just mean What are now these laws of blockchain? Okay, so we now call them consensus algorithms. These are just set mechanisms which are put in place to ensure that all these nodes, remember when I was saying all the nodes will collectively agree that the transaction is legit. That's because they're following a set of rules, right? So we have several algorithms, but the major ones which we're going to focus on today is something we call proof of work, which you're going to see it practically, and then proof of stake. Okay, so proof of work, these nodes or the servers, but let's just start using the nodes, right? These nodes, we now call them miners. I don't know if you've ever had some of a concept called Bitcoin mining. That's because Bitcoin actually uses this algorithm, proof of work. Okay, that's why you hear people, they set up so many miners so that they can be able to mine Bitcoin, right? So these miners now, they solve some complex mathematical puzzles, and then now, by the reason why we call it proof of work is the first miner who solves this puzzle is the one who is going to process the next transaction. Let's go back to our M-Pesa model. If that transaction for Cindy sending money to Jordan, these nodes, they're not going to compete because they've been given like a complex mathematical puzzle, right? So they now begin to compete. And if you're able to get the answer to that question, you now earn the right to process that transaction and then earn the rewards which you're supposed to earn, right? But now this model was not working because if, let's say you yourself, you have one miner, right? And let's say it has like, let's give it 10 GB RAM, right? And then we're having another farmer. I'm going to call them a farmer because there's some people who like have like, let's say 1,000, they have 1,000 miners, right? And they're working on, let's say 50 gigs, 50 GB. They have a lot of computational power, which they will enable them to solve more puzzles quickly, right? So you yourself, by the time you're getting to the answer, someone else has already solved it before you. Okay, so this was bringing people now into competition because you yourself, you want to put as many miners as possible so that you earn better rewards, right? So when it now even comes to the cost wise, it was consuming a lot of energy, and it was also not good for the environment. Okay, so that's where the proof of stake came in. This was now an improvement on the proof of work, right? So this proof of stake, I forgot to add on the network, on the slides, that an example of the network using this is Ethereum. Okay, so Ethereum is actually one of the major network which came up with the proof of stake. This is one of Vitalik's doing, right? So here, instead of now people setting up miners which are competing against each other, we now have this concept of something we call validators. So if you see the terminology called validators in the blockchain space, you'll just know it's involved with the proof of stake algorithm, right? So here, if you yourself, you want to run like a node in the Ethereum network, first of all, there's an amount which you need to lock. Let's say, I think it's like 30 ETH. If is the crypto token for Ethereum, ETH, right? It's called Ether. Okay, ETH. So you lock up, let's say 30 ETH, and this money, you cannot be able to access it for the time being, right? So this money, once you lock it up, this portion of your funds, it is now acting as collateral. Okay, so in the event you're coming in and you're coming in malicious purposes, this money is like as a penalty, it's taken away from you. Okay, now once all these validators take the amount which is needed and they send it to the respective address which you're supposed to send to, and they lock it up. So the network will now randomly decide which validator will run to add the block. Okay, so here, even if you say you're going to add like let's say 1 million nodes, remember it's running randomly. Okay, and also some of the factors which come into place when it comes to proof of stake is the more you stake, the higher your chances of being chosen frequently. Okay, yeah, so that's the one of the conditions, if we can call them. So the more you stake, the chances you are of getting like a higher chance of being chosen by the network. Okay, yeah, so it just picks any random validator to add transactions to the next block. And this concept of a block is where you add the data to the blockchain, okay? Yes, and the validator still and rewards, okay? Yeah, so, and the blocks, this is now where you add your, yes.
Before you go on, there is a question, and there is also something that I want to add more on, maybe the consensus mechanism. So I'll go with the question, and then yeah. So question, this is Michael. He's asking, what happens when a transaction is wrongly processed, or I mistake the address I'm sending to? Can I reverse transaction like M-Pesa from what I've had in Kenya? Yeah.
Unfortunately, once you send money, once you send money to the wrong address, you'll just go and cry in peace because you cannot be able to reverse.
Yeah.
Because remember, there's no central authority. In M-Pesa, that is because Safaricom, they introduced the service of reversing, right? Because they have the authority. But when it now comes to blockchain, there's no central authority. So that's why you're always told to be a bit more vigilant. But also in terms of blockchain, we are also trying to improve the user experience. So so that people stop sending money, and then but once you've just sent the money to the wrong address, that's it. That money cannot be reversed. Yes.
Actually, the reason why we are having this session is so that we can be able to share some of the cool features that Celo has when it comes to social connect, and also account abstraction, where you can be able to use your phone number mapped to your wallet address. So you're gonna be able to see, if you stick along through this bootcamp, you're gonna be able to see some of these cool features that you can be able to leverage when you're building your decentralized application. So onto like an additional on the proof of stake. So Cindy has talked about the validators having to stake. So the proof of stake has had a lot of conflict, whereby people have argued that the pure proof of stake have like people being enriched, the rich getting more richer and richer. And that's where now we have the different types of consensus mechanism in terms of proof of stake. So we have delegated proof of stake, and we also have specifically delegated proof of stake, where you can be able to like choose a delegate, and people can come up together regardless of how many coins you do have, and then you consolidate all your coins together, and then you can be able to do a stake, and then you have a node validator where you can be able now to like validate regardless of the amount of tokens you have. So check out on the different variations of proof of stakes. So we have the pure proof of stake, and then we have delegated proof of stake, and then we have the BFT consensus mechanism and such. Yeah.
Yeah, thank you, Jordan, for mentioning that, because like Jordan has said, I mean, if I've staked 30 ETH, right, and someone has staked 200 ETH, that means they'll have more chances of getting more, to be picked more for processing. So that means they get more money, right? So that's why there are other now coming better improvements on these consensus algorithms, like Jordan has said, the delegated proof of stake. Okay. Yes. So I thank you guys. Yeah, you can continue sharing your sessions. The questions. It means guys are following through. Okay. Yeah. So let's go back to our blocks. Okay. So this is where now the transaction is. When we are saying we are adding data to the blocks, to the blockchain, essentially you're just creating new blocks of which you're going to see practically, right? And then you're adding information to these blocks. Okay. And then they now link each other, and you're going to see why they link and why it's called a blockchain, a chain of blocks. Okay. Yeah. So if you change or you alter any data in the block, it's going to be deemed invalid because it's going to alter so many things following through in the end. That's a very for now it's an abstract way of like saying this, but you're going to connect when we go to the practical session, right? So with that, let me go to the this one. I hope, let me just see if we can. Yes. Jonathan, my screen is still being seen, right? I've
Yes,
flipped
yes.
to
On my side, I
okay.
can still be able to see. I don't know if the guys on the call can be able to see.
Yeah, please,
Maybe
if
they
you
can
cannot be able to
respond with
see,
tabs.
yeah, yeah, you just give guys a 1 minute break to just digest this information as we wait to, if in case you have any technical, if you cannot see my screen, please you can say, but yes, just a 1 minute break to digest all the information shared. Okay. All right. In the meantime, I can introduce the practical aspect of what I want to show. So we are first going to go through. This is a very good site. I'm going to share the link later for you to. It's like a demo of how blockchain works, right? So we are going to go through it from like the very small level, which is a hash, which it was going to come in very when I was talking about the concept of digital signatures, right? And then I also have a program I wrote like last year, although this is in Rust, but we're just going to just show you guys how it is just a very simple blockchain which I made some time back, and just to show you guys the concept of how blocks are created. Okay, so
Yeah,
we're not going to go through the code.
quick one, Cindy.
Okay.
Someone is asking about the algorithms. Apart from the secure hash algorithm 256, if there is other types of algorithms.
Yes. Yes, so
Eh,
the SHA-256, of which we're going to talk about, the SHA-256 hash, this is just one of the hashing algorithms which are used in designing these hashes, right? So this one is used in Bitcoin. And then now in Ethereum, they have another one called Ketchak 256, or if you want, you can call it SHA-3. So most of the blockchains, they have their own set of hashing algorithms, but for demo purposes, we normally use the simple implementation, the SHA-256 hash, which is also what I used myself here.
It's actually one of the popular hashing algorithms.
Yeah, it's one of the
Yeah,
popular hashing algorithms. Okay. Yes. So to continue, first of all, let's just go with this, and then we'll be working with them concurrently, right? Meaning I'll need to okay. I hope you can see my terminal also. Meaning I'll need to we'll be running here also, right? So can go run. Okay. Now, let me first start with the interface, okay? So what is this hash? This hash is something, I can call it like a fingerprint, if you can call it like fingerprint, right? It's a cryptographic representation of the data which you have hashed. No, that's not a good explanation. Okay, it's just, let's example, this is an empty data set. It's empty. Our data point is empty, right? So this hash, it's a digital representation of the emptiness here. It's like saying it's empty. Okay, if I have data set, you can see the hash has changed. Okay, you can see so it's just a representative of this. Normally what happens when we say hashing algorithms, you feed the data to the type of the hashing algorithm which you have used. Example, the SHA-256 hash, which is one of the hashing algorithms, and Ethereum, they use the Ketchak 256, right? So you just feed the data to the algorithm to produce the hash here. Now, why is this called SHA-256? It's because when you go and check it on the technicalities, it's because it produces like a 32-bit hash. This one, if you count this hash here, it has like 64 characters. Yani, I've used Yani. 64 characters, right? So example, the reason why it's changing is, remember, the way you hash is you feed the data and then it produces the representation of it, right? That's why if I even put a dot here, the hash changes. Okay, so based on the hashing algorithm you use, the outputs will be different. Okay, so why are we talking about this? It's because most of the time you will be dealing with hashes a lot. Remember, if we had our transaction, right? The transaction ID I was talking about, if you remember the our analogy for M-Pesa, the one which I was saying, it's like the M-Pesa code which you receive, right? If I say my Cindy sent 100 to Cindy sent 100 to Jordan. Based on this hashing algorithm, it will now represent this transaction. Okay, so this is now like a unique ID which is generated to give out this. Okay, and something which is very interesting, although I stand to be corrected, is you can use the data to receive the hash, but you cannot try to like break the hash to produce the data which is representing it. Okay, so you use the data, you can generate a hash, but you cannot like reverse engineer the hash to produce the data. It's normally work that way because of security purposes, because let's say you might have a lot of private or sensitive information, okay, and you might not want it to be seen, but you want to provide a proof that something happened, but you don't want to show the data needed. So that's why we use a lot of cryptography in blockchain. Okay, so something which is you.
Can I also maybe add
Yes, please, you
as
can.
you take your water?
I'm
So
looking forward to.
something also I would like to add on the cryptography is, so a cryptography has to be like quick to generate, of which Cindy has said it has to be quick to generate, and then once it's quick to generate, it's also hard to like reverse engineer it, and this is where now the beauty of now blockchain comes into like place, whereby you cannot be able to like alter or change the already encrypted data, and with this secure hash 256, the reason why it's recommended, it's because it really takes a lot of time to like reverse engineer. It's actually near impossible, but we're gonna maybe mention some of the challenges with it, and the reason why blockchain is moving towards some of the latest technologies. Yeah.
Okay, thank you, Jordan. Now this is a hash, right? So where do we use it essentially? So remember that the person who asked where you store data, essentially you store it in blocks, right? So we're now going to check a demo for how blocks look like a high level overview. Okay, so we have this block here. It's block number 1, right? And we have this concept of a nonce. A nonce is a number which is used once. I will come back to it right now as we talk about it, right? So essentially, this is how a block looks. That looks like a high level overview. Okay. So in a block, we have the block ID. So to know which blocks have been produced. So we have the block ID, right? So currently we have one block which has been produced, right? And the data, you have to have let's say we put some form of data inside, right? So let's go back to our data, like or something else. I'll explain why you can see it's bringing red, right? So I have Cindy has sent 100 to Jordan. Yeah, so now why is my block coming red? Remember, before even adding any data, there was this hash which was generated, which was for our the empty set, right? Now we have this concept of mining. So example, if this block, let's say, had already been produced and it did not have any form of information here, and this nonce here was essentially actually used also to produce the hash. I'll come back to it why, right? So if I come and add more any information here which was not there in the beginning, that's why the block is becoming red, because this number here, which was used to also generate this hash, the hash is now not following the set rules. Why am I saying this? Let me just quickly take you guys back to the code so that you can see. Okay, this one is a separate, it's not for the demo. Okay, so we have some set of rules which I was talking about, some of the set of the rules which were given, right? If you come back here, I mean, it was this person, the way they've set their rules is a hash is valid, first of all, if it has zeros, 4 zeros in the beginning, right? So if you do anything and you can see it's not honoring the laws which were given, right? That's why the block is becoming red. And what is this nonce you're seeing here? This nonce, remember when I was talking about the proof of work model where miners solve complex mathematical puzzles, right? So one of the implementations you find this miners do is they look for this number, which, remember, it's called a nonce because it's only used once, right? Based on the set difficulty. Why am I talking about a difficulty? Because when you come to my code, I put like a difficulty of 4. Okay, like I said, my puzzles, which the program will be like generating, they'll be having a difficulty of 4, right? So now it is the work of these miners to now start from 0. How do they do it? Example, you come to 0, it is not honoring the how the hash is supposed to look like, right? That's why it's black. You continue to 1, 2, 3, 4, until you get to the yeah. So what was the number? I've forgotten. Let me just refresh. Yeah, 72,608. So these miners, by competing, they now start counting from 0. They continue finding out the number which is going to honor the set of rules which are given, which a proper hash will start with like the 4 zeros. Okay, that's why you're seeing it here. So if I want to update, let's say I have this, the one thing we'll have to do is you have to remind it so that it can find the number, which when it is added, when you're now calculating the hash, because you're going to use the nonce, you're going to feed also the data. Once this number is fed into the hash algorithm, it comes up with the appropriate hash for this block, right? So that's the concept of mining in blockchain, which I can show you guys also here. I hope you can see my terminal. There was the simple blockchain I put on, right? It's also a proof of work blockchain, right? So first we have something we call a genesis block. This is the first block which is given out, right? The first block, okay? So index, it's 0. This is the timestamp, although I have to refine it to like show proper time. And this is the current hash of our genesis block. Okay, as you can see, I set my difficulty to 4, so meaning it has to like follow some of the rules, right? And the previous hash is 0 because this is the genesis block. And then this is the number which, if it was a miner which was mining the first block, it was supposed to get this number so that when they feed it with all the other data to produce the hash, it produces the appropriate one, right? So if I add the data for block number 1, let's say data or something, it will now produce our next block, right? So something I want you to see, how do these blocks link? Remember, our previous hash was 0, right? This previous hash was 0 because this is the genesis block, right? When you come to the second block now, this is the current hash, right? This one here. Remember, it is now referring to the previous hash of the first block, this one. So if you check these hashes, they are very similar. So that's how the blocks connect in the blockchain. So you always have to refer to the previous hash of the previous block to make it for visual purposes. Let's go back to our demo here in the blockchain. Yes, so this is how the blocks will look like, right? So if you check it out, this was the first block, this was the nonce, this was the data. You see, it's a genesis block because the previous one is 0, right? This is its hash. This hash represents everything which is inside the block, like we said, right? When you now come to the second block, which was produced with the nonce, which was figured out as the mathematical puzzle so that it can be able to generate the hash, it now holds a reference to the previous block, which is this one. So when you now go to block 3, it now holds the previous hash of block 2. So that's how they interconnect. Why is that important? If I change something here, everything is rendered invalid moving forward because the hash has changed, and our previous and it affects also all these other hashes in the other blocks. Okay, that's why we normally say a blockchain is termed immutable, because even if you change just a single, if you try to change just something single, when these blocks are let's say there were like 50 blocks in one big chain, and then you decide to like change something from block 7, all the rest will be rendered invalid because they refer back to each other, and these hashes are also interconnected, so that's why they're changing. Okay, so to fix this, you'll have to remind this, and then you'll also have to remind, so you will have to essentially build, or rather produce other blocks. Okay, you'll have to produce other blocks which will follow the updated information. So okay, yeah, ooh, what have I done? Yeah, so you'll have to keep on mining you'll have to keep on mining and mining and mining and make them to be okay, right? So essentially this is how blockchain works, and why we normally love saying blockchain is immutable and you can't change any data in the blockchain and all, because when you change something, it affects all the other things, because your hash will be different, and all these other people, they have different hashes, so yours will now be invalid. Okay, so remember when we were talking about the concept of people joining in, because this is just blockchain, right, in itself. So how do these nodes work together? So they work in the form of peers. So each node, which we now call them peers because it's a peer-to-peer network, right? They have the same copy of the blockchain. So if you're having 20 nodes, you have 20 copies of a blockchain. I mean, in essence, it's a bit redundant, because it's now like you have 20 data sets, or you have 20 copies of data, but that's just to improve on the security of it, right? So all these peers, they have the same copy of the blockchain. Okay. Oh, sorry. So if you change something here, in your peer, if let's say node 1 changes something in the blockchain, and then decides to like let's say just update, right, decides to like remind the blocks again, right? So one thing which will be which is very important, but you have to realize, is for him now, because he has this node peer A, he or she, they have updated the blocks, right? But these other people have copies of the same blockchain, right? So even if you decide to change or update something in the blockchain, when you come back, and let's just check as an example, block number 5, their hash is 0000505, right? When you come and check PRB, they have a different hash, right? This one has 0000505, whatever. This one has 000E4B90, whatever. And the third peer also has the same copy. Okay, so now obviously we will know who's the malicious one, because remember, this peer A changed or changed something within the blockchain, and it was not collectively agreed upon through consensus, right? That's why these other blocks, they don't have this updated copy, because it was not collectively agreed upon through the consensus algorithms, right? That's why peer A has a different set of data in the blockchain with the different hashes, and these other people, because they're following the rules, they have different copies. So this sort of system, it helps to mitigate, it helps to reduce as many malicious actors as possible, because remember, you will continue adding more blocks, and if you don't have the information these other nodes will have, there's some sort of warning will be like given out, right? Because you're broadcasting this information on the nodes which you have to the other nodes. So if this peer A broadcasts or rather they share this information with the other peers, and then the peer B will be like, but you have different information than me, and peer B will go to peer C and check, am I wrong, because I have this information, and then peer A has a different information, and then they go to peer C and they say, okay, we have the same. So collectively, this peer A can now be kicked out of the network, because they're having different things, so be acting maliciously, right? Yeah, so this is just a demo, a practical demo. This site, it's a really good site. I'm going to share it. So it just helps people understand the abstract concepts of blockchain in a more practical manner. Yes. So that's like the foundational concepts of blockchain. In the essence of time, because blockchain is a very extensive what's this term? It's a very extensive what's this term? It's a very extensive discipline, right? So we might not have been able to go through all the concepts of blockchain, but these are some of the foundational ones, right? Because we also have these things like account system, which you also have to go and read about also. But yes, so far I haven't lost anyone. So it's the same with here also. This is how now blocks are produced. Okay, this just shows the concept of producing blocks. Even if you decide to enter something which is it's empty, like the data is empty. So yeah, that's how we build essentially blocks and blockchains. So it's now the work of the nodes to produce the next block. So when we say we produce the next block, they process transactions and then they add them to a new block, and then the new block is added to once the block space. There's something we call the block space. Once the block essentially it's like full of the space of the block space is like full with the asset number of transactions, it's now added to the chain, and now another server another node takes up the responsibility of setting up, or rather adding more transactions to the next block and adding it to the blockchain. Yeah, this is just a foundational introduction to blockchain. I hope you guys have understood. At this point, I think I've talked too much. I'll leave my colleague Jordan to continue from where I have left off. Yes.
You've actually talked a lot.
Yeah, I've actually.
You've given us a solid foundation as we're gonna run solidity, so we need that solid foundation. Let me share my screen. So let's see. Window.
Oh, right. I've just seen a question.
I hope you can
What is
see.
the
You can see. Oh, sorry.
Yeah, what is the daily information is asking what is the minimal requirement to run a node? So actually that depends on the network. All these networks have different specificalities. So if you want to run a node, they always have like they've given you like the set requirements, maybe a set type of CPU, maybe a set type of amount of storage, because you'll be storing all this information on the SSD or the HDD of the server, right? So all these networks, they have set requirements for the type of nodes which they'll be running in their network. So if you want to run a node, the next thing is now following the set guidelines from, let's say, the network which you want. If you want to run on Bitcoin, they've given out like an official documentation. If you want to run an Ethereum node, a Celo node, yeah.
Okay, yeah. So I hope you've gotten what blockchain is and how the different consensus mechanism works, from proof of work to proof of stake, and also being able to like produce hashes or blocks. Yeah, so something maybe to add, Cindy mentioned about gossiping, and I think we can now be able to validate who brought the rumors using the nodes. Yeah. So the purpose for this session is also to like get an introduction of what Celo blockchain is, and understand why now we need Celo blockchain, and yeah. So Celo blockchain is not just a protocol; it's a community of builders and also founders with a mission to be able to create prosperity for everyone. It was founded back in 2020. I think the mainnet was deployed around August 2020 there. Yeah. So Celo has an ancestry code shared with
Just
Ethereum.
a second, just a second. I've just realized. Let me just add your presentation to the stage. Okay. Yeah. I think now guys can see. Yeah, you can continue. I had not added yours to the stage. And you're muted. Hey Jordan, you're muted.
Sorry, I muted, and then you. Uh, so Celo, as like I was saying, Celo blockchain is not just a protocol; it's a community of builders and founders with a mission to be able to create prosperity for everyone. So Celo was launched or founded in 2020, and they really did an extensive research. And previously, they are like one of the first blockchain to be able to revolutionize how the wallets interact with the user. Yeah. So the Celo blockchain have shared ancestry with Ethereum blockchain. So for those who know Ethereum, Ethereum is the second largest blockchain and also the largest token, that is Ether. So Celo is a fork of it, and yeah. So despite the similarities with Ethereum, there is something which is completely different with in terms of the Celo assets that we do have and how Celo is accessed as a network. Yeah. So the mission for Celo has always been to empower anyone with a smartphone anywhere in the world to be able to access financial services and be able to send money to their phone numbers and also be able to pay merchants. If you've been following what Celo has been doing in Africa and in some of our Twitter account, that is Celo Africa DAO, Celo Kenya. We are actually in different ecosystem, that is 5 ecosystems. We are in Ghana, Nigeria, Kenya, Uganda, and South Africa. Yeah. So yeah, that is what Celo is all about. And to be able to achieve this, Celo have a set of core libraries. It also has a wallet application and a lot of other resources that I'll tribute for developers and users specifically. Yeah. So Celo is the native coin. That is the Celo, which is comparable to Ether on Ethereum. And Celo also consists of the different accounts. So we mainly have 2 accounts. We normally have in any EVM compatible blockchain, we have 2 accounts. We have the externally owned accounts. That is where we have the public key and private key. And then we have the contract accounts. So contract accounts, you're gonna see how they do interact together with the public private key account. And then Celo has other assets. Yeah. So if we go into deep on what Celo is and how it does leverage consensus mechanism. So we've talked about proof of stake, which is what Celo implements. But there is also another consensus mechanism which Celo also exercises or uses, and that is the BFT, the Byzantine fault tolerant consensus algorithm, which is well defined for validator nodes to be able to broadcast messages between themselves in sequence and in to reach agreement. So we also have on-chain governance. So in case there is any in Ethereum, we have the Ethereum improvement proposal, and in Celo we have the Celo improvement proposals where you can be able to vote for any changes and how you would want to the community to be governed, and the changes that you would want be implemented within the Celo ecosystem. So there are those core contracts that are used to be able to vote, and you can basically stake your token to be able to vote. Yeah. So you will probably be asking yourself, why would I build on Celo instead of maybe even in Ethereum or in any other blockchain? So one of the reasons for developers to be able to leverage Celo blockchain is that we have fee abstraction, which users can be able to pay transactions fee with different tokens. So unlike when you are using maybe, let's say, like Ethereum, uh, unlike when you're using coins blockchains like Ethereum, you have to have ethers to be able to pay for a transaction. But when it comes to Celo, you can be able to use any token that you do have. I'll go back to the use for M-Pesa. So with M-Pesa, you can only pay for the transaction fee using Kenya shillings or the native currency for your country. If you're doing a bank transfer, you're gonna be using maybe South Africa rand or Nigerian naira to be able to pay for the transaction fee. But now, when it comes to Celo blockchain, if you want to do the same transfer, you can be able to use any other currency rather than the native currency, which is Celo. These currencies are like Celo stable currency. These are like the Celo US dollar, the Celo euro, the Celo real, the Celo Kenya shillings for people within Kenya. Yeah. Then we have like a really low gas fee. At the moment, Celo is a layer one. The mainnet is layer one, which we're gonna be transitioning to layer two very soon. And as a layer one, it has like a really low gas fee, and you can imagine how the gas fee are gonna be lower when we go to layer two. They're gonna be extremely low. Yeah. So with the gas fee, there is a lot of things that we can be able to like talk about the blockchain trilemma, of which we're gonna talk about once I introduce what to look into in the future of Celo blockchain. Yeah. So Celo is a mobile first. It's optimized for mobile devices, making blockchain accessible to billions of smartphones users around the world. We have like a really ultra lightweight Celo client, which allows faster transaction on mobile phone without needing to download large amount of data. Which is ideal for people who are living in the rural areas and who have like limited internet access. We also have a really cool feature which really makes Celo more unique to other blockchain, and it's the phone number mapping of wallet addresses. So Celo native protocol has something we call the social connect, which is able to link wallets to phone number, making it easier to be able to send and receive. If you got into blockchain years before Celo, you would imagine how, from what even Michael was asking, you want to go to Maldives and you have your bitcoins ready, but you unfortunately you send to the long address to cash out, and then your dreams become invalid. Yeah. So with Celo, that solution has been created. Yeah. So there is also incentives. Cindy talked about incentivizing node validators. So Celo has a way to be able to like incentivize users to be able to operate regular nodes. The right node, the right clients are able to pay transaction. Like we are able to pay for transaction fee to like full nodes, and also we are able to like you can be able to like see all the list of the node. We're gonna be sharing the links to the Celo organization and how you can be able to see some of the tokens, especially for the Celo USD, for the Celo Real, you can be able to see the backing of the stable currencies for Celo. Yeah. So Celo is also optimized for global reach. So like we said, it's a mobile first blockchain, which means optimized for global reach, where we have like 100,000 daily active users, proving it's capable to be able to like support larger scale deployment. Yeah. So yeah, then we have a lot of community engagement. Celo is really big. It's active globally. We have a lot of builders. We've had like 4 years of experience here in Africa and in other countries, and we've been able to see different people building from DeFi, from UBIs, from remittance applications. There is a lot of interest and practical use case for Celo blockchain and the Celo blockchain tools. Yeah. One of the thing about Celo which is really unique, Celo is carbon negative. We've had projects like the Toucan project. We've also had projects like Plastica. We've also seen projects which are partnering with Barcelona, the football club, which have been doing initiatives in terms of reducing the carbon emission and also incentivizing people to be more in the area of environment. Yeah. So Celo, since it uses the proof of stake, it's able to use less. It's able to have energy efficiency, and it's also have that avoids energy incentives, mining reducing its carbon footprint. So that makes it ultra green money. So a portion of every transaction uh, goes towards carbon offsetting and sustainability of projects being able to support environmental efforts. So there is a concept called DeFi within Celo, that is DeFi finance. Yeah, DeFi finance. It's regenerative finance. Yeah. Yeah, it's called regenerative finance, which is really big also on Celo. Yeah. So we move on to the future of Celo. So Celo is moving to layer two. Currently, we have the Celo layer two testnet, which is on Alpha Horus. And one thing I mentioned about the blockchain trilemma. So one thing we've seen with layer one, that is the Ethereum blockchain. Ethereum has been able to like focus more on decentralization and security, leaving scalability. Now, scalability goes together with the transactions and also in terms of user access and in terms of even building decentralized applications which are scalable. So Ethereum is really good with decentralization and security. And there is a blockchain, there is a triangle there that is called the blockchain trilemma, which says that a blockchain can only have like two of the three. So it can either be decentralized and secure, and then it leaves out scalability, or it can be scalable and secure, but it leaves out decentralization. But it can never be like completely the three. And I think we've seen some of the blockchains which have tried to focus on the three and they have like failed. So now layer two leverages the Ethereum decentralization and security to be able to scale Ethereum transaction. And that's why now Celo is coming back to Ethereum to be able to complement Ethereum and also be able to like bond together and strengthen the bond. Strengthen the bond to be able to like deepen into the vibrant and collaborative Ethereum community as we be able to like build and develop some of the public goods that Celo has been doing to be able to like even impact more people. Yeah. So that's what it means to our ecosystem. And yeah, so these are some of the key features of Celo Layer 2. This will be like there will be high throughput. So this means it will be able to handle a larger number of transactions per second. It will also have like a lower latency. It will be able to like you'll be able to have quick transaction finality, which provides faster and efficient transaction processing, which is suitable for like paying every day. I know those are some of the questions that most people ask. Like, if I'm able to pay with M-Pesa, why do I need blockchain? But with now the low latency, like the transaction finality being very fast, it means we can be able now to support microtransactions, which the day-to-day user uses, like paying for their gas, paying for their bread and such. Yeah. Then we have cost efficiency. It will have like very reduced transaction fee compared to the Celo mainnet. That is the moment the test net. But once we move on to that, we'll be able to have such. So we also have scalability. So the architecture supports horizontal scaling, allowing the network to be able to grow and manage increased demand without compromising the performance. So we have integration with the Celo ecosystem. It will be the Celo layer 2 will be able to like enable developers to be able to leverage familiar resources and also be able to like maintain compatibility with the mainnet. So lastly, I think I talked about fee abstraction. So the only thing I did talk about was token duality. So this means that you can be able to sell token is both the native currency of the blockchain as well as the ERC20 compatibility token. This means that you can be able to move both by doing a native transfer as well as an ERC20 transfer, and will be able to show up in both the native account balances and such. So yeah, so there will be no token wrapping or unwrapping, which is necessary. It won't be necessary. Yeah. So there is a lot of information that we've talked about today. We want to let you like digest that, and next week we'll come with more. As Cindy likes to say it, we're gonna end the year with a bang, and we are not just gonna create a theory, but we're gonna be creating the bang. Is it the bang itself? Yeah. uh, yeah. So that's it from me. Unless there is any question. Um, Unless there is any question on the chat, or maybe if we would want to continue, because if we start talking, we can talk until tomorrow morning. Yeah.
Yeah, and to just add more info, no, I mean, it's not good to add more because we talked a lot. We want you guys to go digest. Just to give you guys more update, kindly join the dedicated Telegram group, because that's where we'll be sharing the assignment for week 1. The assignment will be it will be super simple because it's a first week. We're going to give you guys guidelines for setting up the development environment, because next week we're going to start on the more technical aspects of it, which will be an introduction to Solidity, right? So we'll give you guys over the weekend. We'll have sent by tomorrow. We'll have sent some of the what's it called? Some of the the assignment which is required, and the specifications which you're looking for. Also, during the period of the bootcamp, we might or we may not be having some sort of rewards. So we'll be having like surprise rewards across the bootcamp.
Hey.
So kindly don't. Yes, some surprise rewards. Kindly don't disappear on us. So, but essentially, the whole goal is just to teach you guys like an end-to-end development on Celo, right? Otherwise, we thank you guys so
Yeah.
much for joining in.
Santa
If you have any
Mary.
questions, yeah. So kindly, if you some of the requirements for the assignment to be successful is once you're done, you're going to like create a short tweet because it's very good to build in public. So and it will be nice to show the progress you're working on Twitter. You'll be tagging us there, so we give you support in your tweets and give you more what's it called? To just give you guys a better audience for people
Lot
to
of
see.
quotes and
Yes, so yeah, so kindly follow Twitter Celo Africa DAO because we'll still send this in the assignment template. So kindly follow Celo Africa DAO because we'll be tagging it a lot. You're also going to tag the main Celo Twitter account. We also have Celo Dev's Twitter account and also our personal Twitter accounts as well, so that we give you support. So that's my Twitter handle, and also that is Jordan's Twitter handle. But then all this information, even with the slides and the recordings for today's class, will be shared in the dedicated Telegram group. That's why once more, I will urge you, if you haven't joined the Telegram group, please do so because even most of the information, in fact, all of the information will be being handled in the Telegram group, right? Otherwise, I just thank you guys so much for joining. I hope you've come out having learned something from the 2 hour session. We've actually had a 2 hour session. So we'll see you guys next week, same time, same place. So for the next 3 weeks, we'll be meeting each Thursday from 8:30 to around 10:30 p.m. East African time. So that will be 6:30 West African time and all. Yeah. Again, if you have any other questions and maybe you didn't ask here, Jordan, do we have any games on Celo?
Do we have any
Let me
games?
just quickly let me just quickly
I think the Scouts game.
or no, the Scouts game. Yeah, we actually have something we call the Scouts game. That's more of an internal joke, but we have a Scouts game. But actually, the ethos of Celo is being more of impact. So we focus a lot on impact. So creating like impactful projects. Not to say that games are not impactful. In fact, if you have like once we continue looking at the Celo ecosystem, if you have a very good game which you believe can help, that now is your
Yeah,
chance
yeah,
because I
yeah.
don't think we have as I
We,
mean I
we,
stand
we
to
are
be
always
corrected
looking.
though.
I think there was a game that used to be. I don't remember the name of the game, but there was one which was built for environmental purposes. It was an NFT game where I think it
Ah,
would be able to like identify animals and such. Yeah.
okay. Okay, so yeah, if you, I mean that is actually a market gap in the space. So as we continue, we hope we will give you guys like enough foundational information to continue learning. And also, blockchain is super extensive. We have not even begun to we haven't even covered like 10% today, and
Yeah.
this information is a lot, right? So continue learning, continue building. The goal for here is not just wait for us to give you info. Being active also helps a lot. So by the time we meet next week, just make sure on your end you've tried to sit down and read more extensively. If you have any questions, you can always reach out to me. You can reach out to Jordan on Telegram through the dedicated. Please tag me through the dedicated target group. Our Twitter, our Instagram sometimes is crazy because you have so many DMs. So just in case you've DM'd us and I haven't seen your message, just tag me in the main Telegram group, and I'll be sure to respond. And you also get to meet some of the team members who will be working with. This we just two, but we have also more who will be helping out in terms of office hour support. But otherwise, I just thank you guys for coming in, for showing up. We hope you've understood everything. For those who are joining in case you've missed the session, we'll provide a recording for it in our Celo. You'll find the recording in our Celo Africa DAO YouTube channel. Let me just,
Yeah.
okay. Yeah, the channel. The channel, the
As
channel, the
Cindy
channel.
drops the channel link, uh, we are all over. You will find us in weird places, preaching about blockchain and also building. So we will be like your guide to be able to like learn more about blockchain and more so about Celo blockchain. And if you're transitioning from Web 2 to Web 3, you will be in a really good chance. The idea is to like spark something in your life so that you can be able to like get started how to be able to like learn more about blockchain. Yeah, so the blockchain field is evolving. We are also still learning a lot about the new changes that are happening within the blockchain space. We started learning, but now we are back at zero knowledge, the learning again. So yeah, so the idea is to spark that thing so that you can be able to learn more about blockchain and also be able to build impactful solution and change people's life financially and also even health wise. Yeah, so we really have a big team. Cindy will be introducing them at times, and yeah, so we really have a good team which will be able to take you where we cannot get.
Okay, yes, we have a big team. So in the course of the 4 week, you're going to meet with them. Otherwise, welcome to the end of the session. Thank you for joining us today. It's been so nice having you guys here. Thank you for the interactions. We feel nice when you ask questions because we know you're following along. So if you have any more that you didn't manage or maybe we missed in the chat, you can always hit us up with like follow-up questions. In the meantime, expect to find your assignment. I'll send it as early as possible so that you start working on it before Thursday. And don't forget, we have some rewards to incentivize you to finish up and it will just be surprise activities during the course of the bootcamp. But the goal essentially is just to ensure you learn as much as possible. And yes, see you guys next week, same time, same place. Bye bye, ciao ciao. So Jordan, do you want to say bye bye to people?
That's how the cookie crumbles, I guess. I'm gonna be working on my catchphrase.
Okay.
But
Yeah,
bye.
see you next week. Okay, bye guys. I'm going to now end the stream. See you guys next week, same time, same place. And yeah, see you. Bye bye.